In this video, we're going to look at some common reactions of acids. More particularly, we're going to look at reactions of acids and metals, acids and carbonates, acids and bases, and then also reactions of alkali metals and water. We'll start with reactions with metals. These are single replacement reactions. Overall reaction, if you take a metal and an acid, you get a salt and hydrogen gas. The asterisk here indicates that the metal must be more active than the hydrogen on the activity series. Metals above hydrogen can replace the hydrogen. They are more reactive. Metals below this are less reactive and cannot replace the hydrogen of acids. So if I take zinc metal, which is higher than the hydrogen of acids, it can replace that hydrogen, and that gives us zinc chloride and hydrogen gas. Remember, hydrogen then is being diatomic as always. Magnesium is also higher than the hydrogen of nitric acid, so the magnesium can replace the hydrogen of nitric acid. This will give us the salt magnesium nitrate and hydrogen gas. This one, to balance, I have two hydrogens, two nitrates, so I need to put a 2 there to balance that reaction. Lithium is higher than the hydrogen of the hydrogen in phosphoric acid, so it will replace phosphoric acid or hydrogen and phosphoric acid to form lithium phosphate and hydrogen gas. To balance this one, I've got 3 hydrogens on this side, 2 on this side, so I need to put a 2 there, a 3 there to get 6 hydrogens both sides. When I put a 2 here, it gives me 2 phosphates, so I need to put a 2 there to get 2 phosphates. Gives me 6 lithiums here, so I need a 6 there to balance that reaction. In example number 4 here, copper is below the hydrogen of acids. Therefore, that is a no reaction. The copper cannot replace the hydrogen and it would not chemically react. Second type of reaction, acids with carbonates or hydrogen carbonates. Here, the generalized reaction, an acid and the carbonates produce salt water and carbon dioxide. This is a double replacement reaction. The hydrogen and the calcium switch places, so that is going to give us calcium chloride and carbonic acid, which is H2CO3, but that is unstable and always breaks down into water and carbon dioxide. So that gives us the 3 products rather than 2. Next one, hydrogen and magnesium switch places. This will give us magnesium sulfate. And then again, carbonic acid, H2CO3, but that is unstable and always breaks down into water and carbon dioxide. That one is balanced as written. Last one, and the hydrogen of the acid and the lithium are going to switch places. That is going to give you lithium nitrate and water and carbon dioxide. The lithium, we have 2 on this side, so I need to put a 2 there. That gives me 2 nitrates, 2 hydrogens, so a 2 there will balance that reaction. Neutralization reactions, acid and base always produces salt and water. So if I take a very strong acid like hydrochloric acid and a very strong base, sodium hydroxide, 2 things by themselves which could be very dangerous, and if I add them in equivalent amounts, I end up with harmless salt water. And so this is a double replacement. The hydrogen and the sodium switching places give me sodium chloride and hydrogen hydroxide or water. Next one, calcium and the hydrogen switch places, giving me calcium nitrate and water. In terms of balancing, note we have 2 hydroxyls here, but only 1 hydrogen here. To get water, I need 1 hydrogen for every hydroxyl. So if I have 2 hydroxyls, I need 2 hydrogens, and 2 hydrogens and 2 hydroxyls will give me 2 waters. Next one, magnesium and the hydrogen switch places. Magnesium sulfate is the salt that is produced, and if I have 2 hydrogens, 2 hydroxyls, that will give me 2 water molecules to balance that reaction. Fourth and last type of reaction, alkali metals and water, another single replacement reaction. The overall general equation, if I take an alkali metal, which is more reactive than the hydrogen of water, so here's the hydrogen of water, only those alkali metals or alkaline earth metals above that can replace the hydrogen of water, and if they do, we'll get a metallic hydroxide and hydrogen gas. So think of water as hydrogen hydroxide. The potassium is going to replace this first hydrogen to give us potassium hydroxide, and then the gaseous hydrogen by itself. So sodium is going to replace the hydrogen of water, and that will give you sodium hydroxide and hydrogen gas. To balance this, we have 3 hydrogens on this side. Hydrogens can only be even on this side, so I'm going to double this one because that single hydrogen is what made the product side odd. That gives us 4 hydrogens and 2 oxygens. So if I put a 2 there, that balances all the hydrogens and oxygens. 2 sodium, so I need to put a 2 there. That balances that reaction. Third and final sample problem, calcium hydroxide will form by replacing the hydrogen of the water, and hydrogen gas then is produced as a product. And then to balance this one, I have 4 hydrogens on the product side, 2 oxygens, so a 2 there will balance that reaction.